I want to just give you an overview of what I want to express today. So firstly, I said data privacy in the age of AI, but let's just have the definition of what exactly is privacy. Well, broadly speaking, privacy is actually to have some sort of control over your personal information. And it's, I mean, the word privacy probably recently has become kind of overused with GDPR, which is, of course, very important. But please remember that this is a human right since 1948, the right to be left alone, the right to not have intrusion or people like looking into your life. So it's a fundamental human right. What is privacy? There are lots of what is privacy, but today we are talking more about privacy related to data, and that's related to data protection. And then you might ask me, why are you talking about human rights? You should be talking to a lawyer. But you as data scientists and machine learning engineers are probably working with massive amounts of data, and you must have also seen this slide from Andrew Ng about how data is food for AI, and 80% of your time is spent on preparing data, accessing data, making sure it's production ready. And in this whole process, you probably are also working with personal data for consumer transactions, for predictions, for recommendations. So there's a lot of personal data involved in your day-to-day AI models. So to begin with, like the question I asked you, what is personal data? And we're going to kind of use the definitions used by the GDPR, which is like the gold standard for data protection, not just in Europe, but across the world. So what is personal data? That means that it's information related to an individual, if you could single them out, so you can identify them, or the likelihood of identification through association. So it's just both direct identifiers and indirect identifiers. So and personal data, not all data is personal data, and GDPR privacy, when we talk about GDPR privacy laws, we talk about only personal data, not trade secrets, not company IP. We're talking about people information, and we're talking about people who are alive. Natural person is somebody who's alive. So usually, like you all mentioned, age, gender, whether they're married or not, nationality, languages, IP addresses are also personal data, because it's an individual, it's a unique link to a personal computer, for example. And even work addresses, home addresses, email, ID numbers, of course. And you have very special categories of personal data, like race, religion, political orientation, trade union membership, biometric data. And these are extremely sensitive data, which require even more, let's say, you have to be super careful. So in terms of data protection and GDPR, what you're already expected, whether you think it's ethical or not, by law, laws like GDPR, they're also spreading all over the world. But let's say the standard was set by GDPR. It became law in 2018, and it applies to anyone in Europe or anybody who wants to do business with Europe. They have to comply with GDPR, and it only applies to personal data, the one we spoke about, and you get a lot of fines if you don't comply with it. And the interesting part is that anonymized data doesn't fall under GDPR. So everybody wants to, whether to use it for machine learning or whether to use it for sharing the data or selling the data, everybody wants to anonymize the data and remove it outside the scope of GDPR. And today's talk is all about why this is actually not possible, and why we cannot anonymize data, and what are the issues, and how do we deal with, I mean, should we stop innovating? Should we stop building AI models? No, obviously the answer is no. So how are we going to work on this? So to give you a kind of an idea, GDPR has kind of a strong clause. It is a European law. It's applicable to 27 EU countries and Iceland, Norway, and Liechtenstein. They are not in the EU, but it still applies to them. And UK also has a GDPR. And every country will be kind of reviewed whether it's GDPR compliant. And many countries across the world, including the US and Brazil, are kind of copying what GDPR requires in terms of how data protection is going to set up. Like California Consumer Protection Law right now is very much like a very similar to GDPR. So what are the principles that you need to think about as GDPR is that firstly, that it's beyond data protection itself. It also has a lot of ethical elements. You need to make sure that when you use personal data for any purpose, whether you want to use it for your machine learning models or for anything else, you need to be able to show that the purpose is fair and it's transparent how you do it. And then you're using the data only for the purpose that has been collected for. So if you collect the data for, let's say, improving customer services, you're not allowed to sell it later on. You have to make sure that you don't use too much data, collect as little as possible, make sure that the data that you've collected is of good quality, and make sure that you don't keep the data forever. And you have the top of the class, cybersecurity and information security policies in place to make sure that the data doesn't have unlawful access, of course, and somebody is responsible for it. Remember the fines, it could be up to 20 million or 4% of the annual turnover of a company. So, and also, especially with respect to AI, there are many data subject rights in GDPR, a right to be informed, right to access, right to change your information, right to be forgotten. You must have heard about all this. However, the rights regarding data subjects with respect to machine learning and AI is about automated decision-making and profiling. So if you're using personal data for AI models, you need to have a lot of risk analysis and assessment about how it's going to affect them, not just from a privacy perspective, but also in terms of bias, in terms of is your model discriminating somebody against others? You can think of, I don't know, if you have a mortgage, automated mortgage solution in a bank, or if you have a behavioral policy pricing for an insurance company, you have a lot of issues with profiling. So, and you might have heard about privacy and stuff just by, when you click the cookies, but there are many more things as data scientists and machine learning engineers that you might need to be aware of before choosing your infrastructure or thinking about your processes and sharing your data. Firstly, in terms of, you need to think about three things when you're talking about privacy. One thing is about the unlinkability. That means that you're able to protect the data and make sure that it doesn't have unlawful access, and also try to anonymize it so somebody else cannot breach it. And then you have to be transparent about what you would do with the data, and also you have control over what happens with the data. So, and in terms of also storage, there's something called where you store this information. Like the United States has something like what's called the Cloud Act, which means that the American government can look inside cloud providers' data, even though the servers are in the EU, doesn't matter. They have the right. It was for anti-terrorism purposes. So this is kind of a list of search warrants that Amazon AWS got from the American government in a 6-month period about them requesting to look at the data. So that's also something like, do you want that to happen with your client data? And also in terms of when you're utilizing cloud providers, you need to think about what's the sensitivity level of the data, and big cloud providers already have some risk classification. So it's also important for you to understand if you have information like race or religion, probably a public cloud might not be a good option. You might want to choose a private cloud. And the next step is the most important part of what I want to talk to you today, especially everybody wants to anonymize data and share it and do whatever they want with it. But there are many misconceptions about this concept as well. Like, what is anonymization? First of all, a lot of us have different notions about it, because not all data scientists are privacy engineers, or privacy is also like a bit of a multidisciplinary field. There is computational privacy, there is the legal aspect of it, and then you have the engineering of it. So it's a very niche branch. So not everybody is on top of what is anonymization. And most often when we ask people about anonymization, they often mean pseudonymization, which is not really anonymized. It's actually personal data. So pseudonymized data, it is personal data. because most often when we are talking about reducing the risk of re-identification, when we look at data sets, most of them are actually pseudonymized data sets. So basically, the simple pseudonymization many of you might have already done is just that you give a code to a name or a surname to make sure that you at least reduce the direct identifiers sometimes, and you keep the mapping table secret. So you keep that secret, and then you work with the pseudonymized data. And you can do also a little bit more, let's say, sophisticated, like using random numbers or counters, where you can also maintain, let's say, the email domain with a pseudonymized email domain, but that is kind of common across everybody. So what happens with pseudonymization, pseudonymized data, is that, and many people unfortunately call this anonymization, this is not anonymization, is that if you have, so this is a pseudonymized data set, and this is like call logs of people and with some information about them. So when you have this kind of data set, on first instance, when you look at it, it looks like a completely anonymized data set, but it's not at all anonymized, because if somebody else has, by chance, extra information about this data point, and just part of this information, they could easily link that information to the pseudonymized data set and can figure out everything about this person. So we call this the linkage or inference risk. So this kind of awareness of what is anonymization and what is pseudonymization is a good starting point. And then there are many anonymization techniques outside pseudonymization. You can do aggregation, of course. You can do data masking. You can do perturbation, swapping, shuffling, suppression. All of this is okay. But you know more than anybody else that with AI models, nothing can be fully anonymous. Like AI models are great at re-identifying the patterns, and you can easily infer a lot of information, even though it's completely anonymous. But the three things you need to ask yourself when you do anonymization in any case is like, can you actually single out an individual? Like, is there a one-to-one risk in your anonymized data set? Can you like quantify the linkability risk? Or can you quantify the inference risk? Can somebody, like I showed you an example, with limited external information can actually make those matches? So even if you do so, this is already 3 years old. We always say that anonymized data is never totally anonymous, because especially with AI, you can't, unless it's complete gibberish, anonymized data cannot have 0% risk of re-identification. So, and even though if you try to reduce the risk of re-identification, you also reduce the utility of it, because if you keep removing information, if you keep reducing the risk of re-identification, then what are you going to do with this data set? It's completely useless. So we always, we like memes. I told you I like jokes, but when we talk about anonymization in a complete sense, this is what you end up with, and what are you going to do with the completely anonymized data set with your AI model? So again, that's why this was the quote that I wanted to kind of make it specific. The data can be either useful or perfectly anonymous, but never both. So what are we going to do? Are we going to completely stop innovating and not use data at all? And that's where I want to introduce you to a new concept of privacy preserving technologies, or privacy by design technologies. I don't have time for everything, and I'm going to talk about the ones that I know well, and what we do well is called synthetic data. It is becoming the new paradigm of privacy in using for AI models especially. To kind of give you a general idea, probably many of you know what it is, but it is fictitious data. It's artificially generated that preserves the statistical properties of original data, but it's similar but not the same. So, with generative AI, synthetic data means a lot of things, but I have a chat. Somebody's having a question, or okay, sorry, no. What we tell about synthetic data, especially for privacy preservation, is actually starting from a actual data set and not generating from scratch. So synthetic data, Gartner has great, let's say, predictions for synthetic data that it's going to drive the data-centric AI, and it's in the hype cycle of 2022. And by 2030, it's expected to overshadow real data in AI models for a number of reasons. Is really as a level up the anonymization standards. It's a new paradigm of anonymization. So you still keep the utility, you keep the statistical predictive properties of the data while reducing the privacy risks. And it can improve model performance because it's you can have data on demand. And you can help work with imbalances, and then you can also use for software testing or reliability testing or cybersecurity testing. And many regulators are also pushing for, the more testing and also utility of synthetic data and privacy preservation for AI, especially as a data minimization technique. And compared to other privacy preservation techniques, European Commission recently said that synthetic data has the best value for performance, the privacy utility function that we are talking about, and all the different regulators across the world, Europe, UK, Canada, and also the United States, are looking at synthetic data as a new way of accelerating AI without compromising privacy. So, and we obviously at Clearbox, we do generate synthetic data, and we essentially start with, even before we generate synthetic data, we have a data profiler, and we run data tests to kind of understand how good the original data set is. And we have like a go, no-go moment where we accept to generate the synthetic data. And once we do so, we provide the synthetic data. We not only provide the synthetic data, but we also provide the usefulness of this data and also the privacy report. Because like I said, even if you have synthetic data, you need to always quantify the risks of identification. And we can help the data scientists also talk to the DPOs or risk officers, saying that, see, with this data set, I can run machine learning models, I can share it with third parties, or I can build a data sandbox, or there are a lot of things happening. So this is just an outlook of our privacy reports. How do we quantify privacy risks, and how do we show the utility, etc. We are already working with a number of banks and insurance companies with this. And if you're actually curious, it's a free platform and a limited one. I'm very happy if you try it out. And we also are working on a GitHub, an open source project, especially on enhancing data quality and privacy metrics. So I'm going to, I think I spoke enough. I was told 15 to 25 minutes, so I hope I stayed within it, and I'm happy to take any questions. Thank you very much.
Thanks a lot, Shalini. Very nice presentation.